Hello and welcome everyone to yet another tech enthusiastic video from Simplilearn. Today we will learn to handle exceptions in Java. But before we begin, please be kind enough to get subscribed to our YouTube channel and hit the bell icon so that you can stay updated about the trending technologies in the current industry. Also, if you're looking for an online training and certification program on the latest technologies like data science, machine learning and artificial intelligence, or to master the cutting-edge programming languages like Java, Python, C#, etc., then please visit the Simplilearn official website to enroll, master and get certified. Now without much ado, let's dive into our session. We will start off with the agenda. First, we will learn the basic definition of an error and an exception. After that, we will learn the basic differences between an error and an exception. Then, we get into the hierarchy of exceptions faced in Java. Followed by that, we will learn the different types of exceptions that we face in Java. After that, we will learn how to handle exceptions in Java using the 5 important keywords used in exception handling in Java programming language. Followed by that, we will try to solve some of the most frequently faced exceptions in Java. Finally, we will go through the best practices that will help us using exceptions while coding in real time. I hope I made myself clear with the agenda. Now, let us begin with our first topic. That is, what is an exception? So an exception is defined as an event that arises due to an unexpected input or logical failure in the program. This may not be considered merely as an error, but it surely does impact the normal functioning of the program segment. Now, these types of exceptions are resolved by the most efficient mechanism called exception handling. Exception handling is not any rocket science, but a simple mechanism that drives the compiler to the next statement by making the compiler understand that the input obtained or the malfunction that arose is just an unexpected or an unnecessary event which can be ignored by sending the user with a relevant message about the exception arose. For a better understanding, let us go through a small example. So as you can see on our screen, we have typed in a program. So according to this program, we are going to access a file called data.txt from the C drive. So this particular data.txt is not really existing in the C drive. So when we run this program, we will face an exception that says file is not found. So let's try to run this program and see. So as expected. So when we run this program, we get that this particular file, what you're looking for, which is data.txt, is not found. Or in other words, it is not present in the specified location. So this is how the exceptions work in Java. Now followed by this, we will move ahead into our next topic where we will understand the meaning of an error. So what exactly is an error? So here, we are trying to learn about the error just to eliminate the ambiguity between an exception and an error. Also further, we will discuss the major differences between them. But now, let us go through the term error first. Unlike an exception, an error poses a serious potential threat to the program, or sometimes it is even capable enough to collapse an entire software. So basically, an error is occurred due to syntax error or some logical error while coding. So we have a sound understanding of an exception and an error. Now let us move further and learn the differences between the both. Error versus exception. So some of the major differences between an error and an exception are: an error is classified under unchecked type, whereas on the other hand, an exception is classified under both checked and unchecked. The next difference is, if a program encounters an error, then it turns out to be completely irrecoverable until the error is resolved. Whereas in the case of an exception, if the program encounters an exception, then the program is easily recoverable. Followed by that, the third difference is, an error belongs to the package called java.lang.error. On the other hand, an exception belongs to the class java.lang.exception. The fourth difference says that an error can be encountered only during the program's runtime, whereas on the other hand, an exception can be expected both during the runtime as well as the compile time. Finally, we will mention an example for both an error and an exception. We can consider the input and output error as an example for error, and on the other hand, we can consider divide by zero exception as an example for exception. So with the differences discussed, we will now move ahead and have a look at the exception hierarchy in Java. The hierarchy of errors and exceptions is really simple. There is one root class called the throwable. Now, the throwable class is basically inherited from object which comes from the superior root called java.lang. Now, the throwable class is inherited by two child classes which are none other than the error and an exception. Further, an error is inherited by different types of errors, for example, JVM or Java Virtual Machine error, memory error, and also in some cases, some of the errors are caused by the incompatibility of the IDE or the framework which you are using. Next up is the exception. Now the exception is inherited by few more exceptions which are mentioned as below. The exceptions can be input-output exception, SQL exception, class not found exception, runtime exception, and many more. Further, the runtime exception is inherited by some more, which are the arithmetic exception, number format exception, etc. Now that we have a good understanding of the exception hierarchy, let us move ahead and check the differences between checked and unchecked exceptions. So the first one, which is the checked exceptions. These are really simple exceptions and can be defined as follows. An exception that pops up during the compile time is called as the checked exception. It is not serious and is completely ignorable. Followed by the checked exceptions, we have the unchecked exceptions. On the other hand, the unchecked exceptions are defined as an exception that pops up during the runtime is called as the unchecked exception. It is considered as serious and is caused by logical errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular example is based on checked exceptions. So basically, we have a text document called data.txt in the location documents, username, users, C drive. So this particular data file has 5 lines. So we are going to access the starting 3 lines of this particular file, and basically when we try to run this program, we will face some of the major exceptions, which are unhandled exception type input output, and again the same exception, and here file not found exception. So these exceptions are errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular code segment here is trying to read a document from C drive, which is data.txt. So this particular data.txt has 5 lines of text. So what we are going to do here is try to type in a for loop and try to read the first 3 lines of this particular document. So basically when we run this program, we will face some of the exceptions called file not found exception, input output exception, and another input output exception. So we can resolve this particular program with small modifications to the program, and then if we run this program, then we can find our lines. So the lines in the data.txt file were, hello, welcome to Simplilearn. We are an e-learning company. Our certification is recognized by major MNCs. Enroll and upskill. So this particular example was for checked exceptions. Now, we will also go through an example for unchecked exceptions to learn it in a much better way. So this particular example is based on unchecked exceptions. This particular program is really simple. we have an integer type array, and inside that we have 10 elements, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what we are going to do is we are going to access the 11th element of the array, which is not really present. So this should throw an exception. So array index out of bound exception is one of the example for unchecked exceptions. So with this, we will move ahead into our next topic. Now we know what exactly are checked and unchecked exceptions. Moving further, we will slowly dive into the process of exception handling. In the process of exception handling, we have 5 major keywords. So we will learn each one of them as follows. So the first one is try keyword. The try keyword is used to specify the exception block. In a program, when you specifically type the exception that you might expect to face in your program, then you describe it using the keyword try. Followed by that, the solution for that exception will be defined in the catch block. So the catch block is used to specify the solution. Finally, the finally is a keyword which has the executable code which is completely mandatory for a program to execute. Followed by finally, we have the throw keyword. The throw keyword basically throws the exception when it is found during the runtime. Followed by that, we have the throws. The throws keyword is used to declare the exception. So basically, this is where you declare the kind of exception you are going to expect in your program. Sometimes you might try to type in your user-defined exception, or sometimes you might type in the exception that is default in its way. Or in other words, it might be system-defined. Now that we have a good understanding of the implementation of the exception handling in Java, let us move further and solve some of the most frequently faced exceptions in Java. So with this, we enter into our 7th topic, which is common exceptions faced in Java. So the first one is the array index out of bound. So if you try to store a value in an array or try to access an element in an array which has an address exceeding the array's maximum location value, then this particular exception is thrown. So to understand this particular exception, let us go through a practical example. So as you can see on our screen, we have an array of integer data type. So we are going to store the values 10, 20, 30, 40 and 50 in 5 different locations of the array, which is 0, 1, 2, 3 and 4. Now we are going to provide the address of the required element. So during that process, we are going to specify one location which is more than the maximum location of the array. So here the maximum location of the array is 4, and if we try to provide the location 5, then this program should throw us an exception. So let's try to run this program and see the output. So as you can see, we have our array here. Now the program is requesting us to provide the address of the element required. So what if we provide 5? So now it should throw an exception. So this exception is the array index out of bound exception. Now let us try to run this program again and specify the proper address. So for this time, let's provide 4 and see if we get the output. So as you can see, at the address location, we have the element 50 as we have defined here. Now our program is running perfectly alright. Now let's move ahead into the next type of exception, which is none other than our null pointer exception. If you try to perform an operation on a null value, this particular exception is thrown. So might be a little ambiguous. To understand this particular exception in a perfect way, let us go through a practical example. So here on your screen, you can see that we have a program, and inside the program we have a string called str which stores a text called Simplilearn. Followed by that, we have another string type which stores a null value, which is abc. As you can see, abc is equals to null. Now here we are going to access the value of ABC. So here the string ABC has a null value and we are trying to access it. So this particular code segment should throw an exception called null pointer exception. Now let's try to execute this code. As you can see, it has thrown an exception called the null pointer exception. So whenever in Java, if you try to access the null values, then the null pointer exception is thrown. Followed by this, we have the next type of the common exception, which is the number format. If you try to store a value with wrong formatting, then this particular exception is thrown. Now to understand this in a much better way, let us try to execute a sample program. So here on the screen we have a sample program where we are trying to cast a string into integer. So this kind of operation should throw an exception. So as you can see, the program has been successfully compiled and we have our exception here which says number format exception. Followed by this, we have another most commonly faced exception, which is the arithmetic expression. If you try to divide a number by 0, this particular exception is thrown. Now let us go through a practical example. Now you can see we have a sample program on our screen where we have two particular numbers, n1 is equals to 0 and n2 is equals to 100. So here what we are trying to do is we are going to divide the number 100 by 0, which is practically not possible. So when we try to execute this particular program, then we should be getting an exception that says you cannot divide a number by 0. So there you have your personalized message which says the divider cannot be 0. Try a different number. So this is how the automatic exceptions work. So with this we have come to our last topic, which is the best practices to be followed while working with exceptions in Java. So the first one is use exceptions conservatively. So exceptions have proven that they can be costly if used recklessly or unnecessarily. So it's better we use Boolean values to indicate successful implementation of smaller operations. For example, if you specify a particular operation and it successfully gets executed, then you can just notify the user by specifying a Boolean value which can be 1, or in the case of failure, you can just specify the number 0. Next after that, we have the customized exceptions. It is a very good practice of customizing your exceptions in the design time rather than planning them on the go. So in other words, we can consider this as if you're planning to design a software, then in that particular stage itself, you must also evaluate the kind of exceptions you might face on the process of designing. So tomorrow if you completely design a software and suddenly an exception is popped in your head, then designing or including that particular exception in your finished software might be difficult. So it's better you start planning your exceptions. Followed by that, we have exception logging. Keep track of the exceptions, and this process comes handy as the user understands why exactly a particular exception has popped up. Followed by that, we have early throw and early fail. An exception should be thrown as early as possible and should be resolved in the same pace. And then we have the closing resources. Since exceptions halt the complete program, we must make sure that the system resources are shut so as to save the resources. So with this, we have come to an end of this session. I hope this was resourceful. If you have any queries regarding this session, then please feel free to drop them down in the comment section below. Also, don't forget to get subscribed to the Simplilearn YouTube channel and hit the bell icon to stay connected to us and get important updates based on the current IT. This is Ravi signing off. Thank you. Until next time.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.